All right, so we're up to the official 128 stuff today, and the most important thing is I'm getting some tweets and comments from students who are having trouble installing their emulator, which I expected, but Caitlin, a friend of mine, had a very good suggestion which may help you a lot. So if you go here to the projects, I've added a new section up here. What I would recommend is if you haven't already got one of these working, ignore all of this and start with these instead. Android Studio is Google's development environment, and it includes an emulator, which turns out to be good enough. When I used it several years ago, it was not good enough, but now it is, and I'm even able to put the emulator on the M1 Mac, and it works. And on the Intel Mac, and I'm pretty sure it runs on Windows too. I see a lot of people doing it. I haven't tested that yet. So I think you'll be able to do these projects instead of all these, and it'll probably work more likely to succeed the first time without too much trouble. All these other emulators are very poorly designed and not really up to date and constantly giving you trouble. So I'll demonstrate stuff like this later, but if you're having trouble with your emulator, try just using Android Studio and you might find that it's very easy. Although there are problems, of course, on the M1. Even this one has a few defects, but it's pretty good. Anyway, that's the first thing. And let's see, comments. What's Caitlin's Twitter handle? I'll put it in the chat. It's Caitlin Guru, K-I-T-L-Y-N Guru. Go ahead and tweet her. That's good. All right. And so for today, I want to start talking about a couple chapters in the book. Chapter 1 and the first part of Chapter 6. So let's look at that. And then I'll demonstrate these projects with the Android Studio that I've got working here on the M1 Mac. So I don't have to remotely connect to a different Mac to do demonstrations anymore, which is very nice. All right, so I'll make this big. I don't like using the presentation mode because I'm always switching to demos and stuff. All right, so this only goes up to a couple of years ago, but the point is Android and iOS essentially own the entire mobile market. Android is bigger. The Android devices are cheaper. And there's a lot more of them. They flooded the zone with many different levels of devices, including very expensive ones. And so Android has most of the market. And iOS has essentially all the rest of the market. Those are the only two we're talking about. So if you talk about the attack surface, these are ways that you can send an attack to an application running on one of these devices. You can send it over the Wi-Fi. You can just steal the device and then try to steal the locally stored data off it. And this is essentially what police do. When they catch a device at a crime scene, they try to get all the data off it and get the pictures and the SMS messages and whatever else they can find on it. You can put malicious apps on the phone. The Google Play Store for Android is notoriously dirty. They do not clean it well enough. A lot of people put malware in the Play Store, and they never seem to be able to get it all out. The Apple App Store is much cleaner. They're much more effective because Apple will not let you put anything in the store without you signing up with a real credit card to prove they know your real identity. And if you put any malware in the store, they ban you forever and you can never sell another app. And you can make real money selling apps in the iPhone App Store, so developers do not want to get banned, so they don't put malware in the store. This administrative control has proven very effective. Google apps are all free. Nobody makes any money anyway. They don't make you verify who you are, so when you kick somebody off, they just make a new account and come back in. And so it's the problem with the open source freedom. Apple is much more like a walled garden, carefully regulated.
They banned Fortnite just for secretly trying to add a new payment method.
Yes, and that's another thing about it. Good thing you point that out. Another problem with Apple's system is that they are very greedy. They take a 30% commission on everything. They won't let you collect any money without going through them so they can take their cut. So, in fact, they might even be broken up by the government. The government is trying to get, like Elizabeth Warren and such, are trying to break up Apple and stop them because they say they're extorting everybody through the Play Store and inhibiting innovation and taking a ruinous amount of money, all of which is probably true. But it does mean that if you have an iPhone, you have a relatively safe experience. You don't really have to worry about malware. And there's a lot of other ways data can go in the machine. NFC, radio connections, the Bluetooth, microphone, SMS, and all these things can in principle be used to send attacks into the phone. So here's some common vulnerabilities: leaking sensitive data. over the network or elsewhere, hard-coded passwords and keys, often hard-coded API keys. In apps, people that don't understand that it's pretty easy to retrieve the strings from an app, and it's very easy to retrieve anything from an Android app because you have essentially the source code. Injection, like SQL injection, and lack of binary protections is almost universal, which is what we'll do quite a bit in this class, where they don't actually verify that their code has not been modified before running it, so you can make a fake app that looks just like the real one, but has Trojan functionality in it. An insecure transmission, insecure storage are also extremely common. So the fundamental problem, obviously, is that the developers do not understand security, and this is true in the whole cybersecurity ecosystem, not just mobile apps, but also web apps and all other apps. Developers don't typically learn security in development classes. So they usually make something work to where when customers come in using it as intended, it works, and they don't know about what the security problems they should be worried about. And so, all right. Here's an OWASP top 10. I think this might not be the latest version, but it's pretty good. Weak server-side controls. One interesting thing about this list is that the number one vulnerability on the phone is not on the phone. It's on the server that it communicates to, an API vulnerability. The way it requests data from the server typically doesn't have good controls, so you can make requests and do unauthorized activities on the server. And then, of course, insecure storage of the data or transport of the data or leaking it somewhere like the log file, not keeping track of who people are or verifying permissions, not using good cryptography, things like SQL injection, taking untrusted inputs and taking those to make security decisions, like you trust a cookie that comes from the user to verify them when that cookie can be forged, not keeping track of who people are in sessions, and the one I mentioned before, lack of binary protections, where you do not maintain the integrity of your apps, you allow counterfeit apps to imitate it. So those are the big ones, and so here they are. The most critical issue is not a flaw in the phone, it's a flaw in the server. We talked about these things. Broken cryptography, often a hard-coded key. And all right, so there's a lot of mobile security tools out there. There are deliberately insecure apps for practice and a variety of other tools, although I haven't used these other ones, and I think we're not going to use them this semester. You can do a lot with, yeah.
Yes, so what do you think about like Apple being pressured to allow third-party app stores? What do you think will happen?
Well, that's what Elizabeth Warren and other people want to do. They want to force Apple to have an open source store. And if they did that, I think it would be as bad as Android, if not worse. And that's why they're resisting it. They're claiming that it's okay for them to charge this money because they make you much safer. And I think if they did open up a third-party store, immediately would be full of malware, and everybody would start stealing all the stuff off the Apple iPhones that don't have any defenses, and the customers don't think about security. So I think it could be pretty disastrous. So I don't think it's going to happen. What I think is going to happen is they'll probably have to cut that 30% down to a lower number. I think they've already started doing that. They've begun to realize they can't be quite as greedy and get away with it. They've cut it down to 15% for some apps. I think if they cut that down to like 5 or 10%, then the pressure will come off. And that would be a lot better than opening the App Store to just everybody.
Even 5% is like, they make like 2-3 billion a quarter. So even 5%
What's that?
is pretty big.
Oh, well, you can argue. But yeah, I mean, certainly Apple, Apple's the richest company on earth, at least it was at one time. At one point, they were richer than the entire U.S. government. They got an incredible amount of cash. So, yep, you're right. That 30%, they're making a mint on that.
Did it all start from the Fortnite thing? Is that where it all started?
No. It started, it's been going on for years.
Oh, okay.
Many app developers and companies have been complaining and suing Apple for many egregious abuses. Another thing Apple does is they'll approve your app and put it in the store. Then they'll clone it and make an imitation, put up the Apple version, and then kick you out for competing with them. They do that kind of thing a lot. So this is what Microsoft used to do this crap all the time too. When you are a monopoly, you just shove everybody out of the way and take all the money, and that's what they've been doing for a long time. And they have an extremely loyal fan base. People who just buy Apple stuff and nothing else and pay a lot of money and never question anything they do. So there's sort of there's no guardrails on Apple's level of abuse. And so it's been slowly building up. A lot will depend on the next election, of course. Yeah, they're only going to be able to punish Apple if the Democrats hold on to the House and the Senate, I imagine. anyway, and so I'd already talked about the research last time I did, finding a lot of apps with vulnerabilities, banks, stock brokers and insurance companies. A lot of these have vulnerabilities, and you'll be using a lot of old versions of apps that have these vulnerabilities in the projects. All right, and let me take a look at the chat and see if anything's coming up here. Will we be downloading an SDK and tools? Well, you'll get the Apple Android tools. Well, the only thing you need is ADB. So you install Android platform tools. We'll use those. There are still some risks, like Xcode Ghost. Yes, there are some risks. It's not like there is zero risk on an iPhone, but the risk is much smaller. There was a count a few years back where at that time there were 100 million Windows viruses and 1 million Android viruses and 100 iPhone viruses. So the risk, while not zero, is much less. Good. All right, let's take a look at a Kahoot. I think we're down to the Kahoot here. Let me see if I got a browser window up here. I do. All right. All right. All right. Let's see if I'm in favorites, or I've got to go in my 128 folder. All right. Wait, did not go to favorites. Perhaps it did. All right. Anyway, let's go out there. But library, my folders. There we go. 128. All right. There. One. All right. Good. See Rohani asking questions. For 126, you need a real Windows virtual machine. And for 128, you need an Android emulator. They're really quite different. And I wouldn't bother buying hardware for 128. You can just use an emulator. It's enough options here, you can probably get one to work. Now, why I can't see, I'm not sure what you mean there, Rohani. Please send the link. Again, I don't, for Kahoot. All right. It is up here on the screen, kahoot.it. You go to kahoot.it and then you put in this number. You should see it in the Twitch. I did, it's asked to sign up. Nope, you must have gone to kahoot.com instead of kahoot.it. Yep, there you go. Good. All right. I'll get my document up to record the scores. Good. Eight, 29, 22. All right. We're up to 14. Rahani's in. Is anybody here still going in? You're already in. All right, well, let's give it a shot. All right, so what's the most popular OS? All right. And so Android, of course, the most popular. because you can get cheaper Android devices, presumably, cheaper apps too. All right, what's the most common vulnerability? All right, yeah, that's it. Lack of binary protections. The least serious but most common one. And what's the largest security problem? Yes, the servers. At least as of that list that's from a few years back. All right, if you place passwords into the log, which vulnerability is that? That's data leakage. It's not storage. You don't store data in the log, although I suppose you could look at it that way. We don't think of it as storage there. It's leakage. It's data going to somewhere where it should not go, where it can be viewed by other applications. All right. Although it's not as easy to view it with other applications in modern versions of Android. Luca, Shang-Chi, maybe close enough to real names for my grader to figure it out. All right. So let's take a look at the next one. That was 1, not much to that. And now I'm skipping up to chapter 6 because we're going to do Android first instead of iOS because we can do the hands-on projects in Android. And when we talk about iOS, you'll mostly understand iOS by comparing it to Android, which you'll know by then. All right, so we're moving over to analyzing Android applications, and this chapter is big and important, so I've split it into 3 pieces. So we're going to talk about making your Android environment and understanding the applications, and the rest of this stuff will come in a later lecture. So creating an environment, this is in the projects, you've hopefully been doing this. Android Studio is, I think, now the preferred way to do this. You get a full environment to develop apps, and we can also just install apps and test them the way we're going to test them. We're not going to develop apps in this course, at least I haven't in the past, although it might be nice to patch the holes in apps. I don't yet have those projects. That would be good. But we're going to certainly find the flaws in apps here. So Mac or Linux is the best host OS, although I think Android Studio now runs pretty well on Windows. So I would say I used to prefer BlueStacks. I think Android might be even better, and we might use Kali Linux. I've used it in the past. Yeah.
Do you think, like, if I'm on Windows and I already set up BlueStacks, can it like be worth it to switch over to Android Studio?
Yeah, I wouldn't worry about it. If you do, it's worth extra credit. As long as you get one that works, you're fine for a while. Setting up the other ones is worth extra credit. And if you do have BlueStacks on Windows, I think you will discover that you eventually have to also have Knox.
Yeah, I did both of those.
Yeah, if you got BlueStacks and Knox working, you can probably do everything on Windows. Just some people are having trouble. Android Studio, but the others are not necessary, probably. But Android Studio is a good thing to know. You won't have wasted your time if you play with it. All right, so ADB is the main tool. Now, of course, mostly you just use your Android emulator the way it looks, either by dragging things on and using the GUI. But aside from that, the main tool you use is ADB. ADB lets you install apps, get a shell, read the logs, have direct command line control of the Linux system. And you can do a lot with that. So you can ADB monitor to see processes, you can manage your emulators, you can package source code in binary form. We'll be building apps later. I'll be using an APK tool instead of this for that. And so Genymotion has a lot of emulators available, even more now. They all do. Let me get my emulator going here. I'm going to launch my Android Studio. None of them work on the M1 except Android Studio. So that's why I ended up here. So in Android Studio, which is here. Come on, it's not moving. All right, so here's Android Studio. And If you do the project here, this one here, in 140, you install this thing, and then you create an emulator. It's really pretty easy. You just install it with the default settings. Then it'll ask you what activity, and do the Google Play activity, so you can get an emulator with Google Play in it, so you can download apps from the App Store. Then you go over, oops, I got to make this thing somehow scroll to the right. There we go. You go over here, and, oh, that's rude. If I refresh, it should grow a little yellow outline there, and it does. Click on this tab to see the device manager, and then you can create a device. When you create a device, you have to specify the hardware and the software. First, you can choose the hardware, and what I would do is choose one that supports Google Play. This is an issue in the real world too. You can buy cheap Android tablets that do not have Google Play because they do not meet the security standards of Google. Google has requirements to put Google Play on something, and only some of the emulators have it too. So get one with the arrow. I found the Pixel 3a worked. And on the here, you choose an image, and there are various images you can choose. I went to the x86 image and got this one, which worked on the Mac Intel, but on the M1, you have to use a different one on the recommended tab called APT31. Most of them do not work on the M1. It's surprising that anything works on the M1 at all, and it's buggy, and only one of them seems to work. Anyway, then you can increase the storage of your phone. I see various videos that recommend this, I think just so you can put more apps on it. It's not really necessary. And then you can start your phone. So there's a run button over here to run your phone. And again, if you're on the M1, you have to make an adjustment or it will not launch. It'll just start launching and freeze. You have to turn off this thing called launch in a new window. Once after that, you get an emulator running, a little phone here, and you can move it into a separate window. And so, let me see if I can get mine going here. Here's Android Studio. So I can start this phone. And that launches it, good, and it does launch in a separate process, which is kind of nice, like Genymotion. And there we go. I get a desktop, and I'm going to get the Google Play Store and everything. It's really nice. You have to try a lot of settings, and I gave you the ones that worked for me until you can get it to actually boot up that fast. Can you close that curtain back there? It's shining in my eyes and bugging me. Hit those things on the side. One or the other of them ought to move it down. Yeah, that'll do. Remove that thing down if you can. Oh, good. That's better. Thank you. Anyway, so now I've got an emulated phone. I got the Google Play Store here where I can install apps. And I've already signed in before. It seems to have forgotten about me, but I might have to do it again. That's not too important. If you go up, all right, this will take me home. You also have Chrome by default, which is nice. Nice to get a Google device. All right, so that's the joy of an emulator. Now I should be able to connect to that with ADB. I just installed ADB right before class, right here. If you have a Mac of either with the Intel or with the M1 chip, you can install it with Homebrew. Once you put on Homebrew, and you can Google how to do that, then you can install this thing with Brew, install Android platform tools. That's what I did, and there. This is, all right, I ran Brew. And there you go. This is the command, brew install Android-platform-tools. And this will be in the projects when we get there. Then you can have ADB. So now that my emulator is running, I can do, let's clear. All right, I can do Android debug bridge, devices, -L. And you see there is a device emulating something here. So I can do ADB shell. And now I'm on the emulator, I'm in the Android operating system. If I do PWD to see where I am, I'm at the root of the system. So here's the stuff you'll see in your Android system. There's a bin, a config, a data, mount, proc, SD card for storage, Quite a few of these are standard Linux folders like etc and such. It's essentially very much like Linux. If you go in the data folder, should be another folder called data. And I'm not root, so I can't get in there right now. All right, and I'm not going to be root today because rooting this emulator, although it can be done, I haven't figured out how to do that yet. But anyway, let me go back to my slides. That's how you get a shell on your device. And so, of course, your emulator doesn't have a lot of the hardware that a real phone has, which is one of the many reasons why you can't analyze Android malware in an emulator. If you try, you won't get much done because the malware detects that you're in an emulator and doesn't run. You got to buy real devices if you want to analyze malware. We're not going to do that in this class, at least I haven't done it previously. So there's all these different ones running in VirtualBox that run on Windows, and there's others. But like I say, Android Studio is probably your best bet now. So the Android is a modified Linux kernel, and it runs virtual machines called the Dalvik virtual machine, which is a variant of the Java virtual machine, and it's running apps written in Java. There are some native code apps running, but almost nobody does that. Almost everybody writes everything in Java. Every app has its own user ID. This is the Android security model. Every app runs in a separate user account and is not allowed to look at the other app's data. That's the barrier. That's why developers think it's okay to store secrets in the storage space allocated to one app, because supposedly no other app can get in there. Unfortunately, there are ways to get in there. All right, so if I run a series of apps, say on a Linux machine, like Solitaire and a web page and a calc, if I do process and list them, I will see that they're all owned by the same user. They're all owned by student. On a normal desktop machine, you log in with an account, and everything you launch runs with that account's permissions. That's the way everything is. This is not what happens in an Android phone. You see all these different processes running. They're all owned by student. Anything you launch from your desktop runs with your account. But on Android, every app runs under a different user ID, unless you carefully avoid that. So if you have a root account and you do PS minus capital A, you can see all the running processes, and you'll see here's the system, here's root, and here's all the apps. They each is installed as user 0A and then a number. I got A5, A73, A52. Every app that's running runs as a different user. Like all these different users are logged in at the same time. That is the Android security model. Data is where all the apps live. In this folder, you will find a subfolder for every app, and it has the name of the app sort of backwards for some reason, like a backwards URL, askalawyer.smallbusinessmarketing.com. That's the way they do it. So each app lives in a folder, and this tells you which user that app is owned by, with a number. And in there, you'll find the APK file. The apps are installed as single files, APK, which are just zip archives of all the pieces of an app. That contains everything. And the APK is stored on your phone, and then it's unzipped and runs on your phone. So you have 2 copies of every app on your phone, the zipped version and the unzipped version. All right, so the XML resources are turned into a binary form. They're not directly readable. You have to unpack them. And there are various other commands you can use with APK to convert parts of the code into other formats. But mostly I use APK tool for that, and that's what we're probably going to use this year, although I'm going to see if they've updated it enough. All these things, you just have to pick whichever tool has actually been updated best. APK Builder lets you build your own APK file, and jar signer is used to sign a Java archives. All right, someone says when I tried Android Studio last year, yes, it's using Qemu. Yes, Android Studio is using Qemu, but now it seems to work. All right. Yeah.
So when you assign the APK to do what?
Oh, you have to sign it. It will not install anything that's not signed. That's part of the Android security model. You have to sign your app, then it installs it, then it knows who you are. And then if you try to update it, you have to have the same signature. That is the only part of the Android security model. It's a self-signed certificate, and it's free. So you can sign anything. You can sign an app that came from a bank. But then, if you trick people into installing it, and the bank doesn't have binary code protections, it would run and look like the real app. But if you tried to update the existing bank app with your imitation app signed by you, it would not accept it. It won't let you update unless you have the same signature. That's the only security you get from it. Whereas in Apple, you have to be signed by Apple. You have to submit it to their approval process, and they have to verify it, and then Apple signs it, and you can't control that. So that's why you can't just put an app up and get it in the store. You have to go through them.
Well, actually about that, I remember many times when I used to do jailbreaking, there would be these websites that say, these apps have been revoked, these are signed by a new Chinese or whatever.
Yeah, if you have a jailbroken phone, then you can put anything on your iPhone.
That's not jailbroken.
Really?
That's on not jailbroken devices. There's like these third-party website app stores that
Yeah, but you
use
have,
temporary signatures.
yeah, temporary signatures, and you can also do side loading by putting on a profile.
Yeah.
Yeah, I mean, you can put a profile on your iPhone that lets it install things from other stores. So you can modify your iPhone so it will take these unsigned apps, but most people don't do that. That's true. It's a good point, though. And that's, I think, that if I was Apple, I would use that defense in court. If they want me to have third-party stores, I'd say, well, people that want that can do side loading, but they're going to have to accept all this risk of malware. And they already have that option, and almost no iPhone people use that. Yeah. I thought you...
No, you already answered my.
Yeah, good. I'm glad you bring these things up. These are very good points. All right, so your APK has a bunch of folders in it. And the Android manifest.xml is a text document that has the main properties of the app. And then you have a few folders with more information, assets, resources, layouts and such, and libraries. And you'll have subdirectories for the different platforms. Your Android operating system can run on many different types of hardware. Another complexity Apple doesn't have. It can run on x86, ARM, or MIPS processors. And some apps target only one of these, and then they'll only run on some hardware. Some apps come with multiple copies of the app compiled for different hardware, so it can run on any of these. Meta-inf contains the certificate of the application that we were just talking about. You have an RSA certificate to sign your app, which has a public and private key, but it is not verified by any certificate authority. You didn't have to pay for it. It's just self-signed. The only purpose of it is it'll be recognized if another app is signed by the same certificate or not. All right. And so here's what the Android manifest.xml looks like, just an XML document. You have some header information here, and then you have some properties. Like here, it's going to have an app. There's that Ask a Lawyer app. And here's the permissions of that app. It can access the network state, your course location, and your find location, so it gets your GPS coordinate and other things. These are the permissions approved for that app. So you got the executable code is in the classes.dex file. The strings and such are in resources.rsc. So when you install packages, there's a thing called the Gtalk service that maintains a connection to Google by pinned SSL, which means not only does it do an HTTPS handshake, it knows what that certificate should be. And if you try to run it through a proxy and another certificate, it won't take it. It makes sure it's really connecting directly to Google and no nonsense. And it fetches the apps that way from Google Play. There are alternative app stores out there all over the place, though, because there is no requirement to install things only from the Google Play Store on Android. And the Amazon is one popular one for the Kindle. So you can install apps, open a command shell, push files on the device, pull files from the device. We'll do that quite a lot. That's how you get copies of the app off the device. You can just pull the APK file off and store it, and that's what we're going to be using in projects. Many of the apps I found that were vulnerable, which are used in projects, have finally been removed from the store, as people are finally wising up. So we'll use old copies I saved from years ago to get the old versions of these apps to find simple vulnerabilities. All right. And for that matter, I don't know if I'll be able to do the log anymore. Let me try dblogcat. I might need to be root for that now. In earlier versions of Android, yep, I'm not allowed to do it. Wait, ADB, oh, I'm already in here. Just logcat is all I should need. Logcat. Oh, there we are. I can see the log. Ha. Yeah, and I'm not supposed to be able to do that without being root. Well, I guess I can again. Neat. And that's what I mean. If any app can see the log, then putting your data in the log is a poor activity. All right. Anyway, BusyBox, if you have a Linux system, and in particular an Android system, it's often stripped down. To run your Android phone, you're not going to be developing on the Android phone, so they take away most of the Linux utilities. The same reason why most desktop versions of Linux don't come with compilers. So what people often do is install BusyBox, And then you get a whole bunch of the familiar Android tools to work in your Android system. It's usually already included with emulators, but it's not included on real hardware phones very much because it's only supposed to be running apps. You're not intended to be developing apps on there. You can list packages and see the path. Again, I probably need to be root, pm list packages. Well, there we go. Neat. I don't have to be root for this either. So here's all the packages on my phone. And see, most of them are from Google or Android, because I haven't installed much of anything on this phone. The only thing I haven't installed on this phone was Qt. So I should be able to find that with pipe grep Qt. I gotta have grep, not ngrep though. And didn't find it. Okay, I have installed a thing called Qt on here, but maybe it's got a different name. Anyway, all right. So you view the logs, you can get system properties and see status of services. We'll use this later if I can get this running on this emulator, which I think I can. There's a tool called Drozer from a research company that wrote this, which gives you a way to more automatically control your device. It's not absolutely necessary. All it is a convenience feature that essentially using ADB to do this stuff. But you can put an app on the device, and what you can do here is you can test whether a malicious app could attack the other apps on your phone. So you put this app on it, which is like a interpreter shell. If you've taken the 123 class, it's a bot. It gives you an app that is remotely controlled on the phone, which is what you get if you trick someone into installing a malicious app on their phone. And then from that app, you can try to steal the data or affect other apps on the phone. So we'll have a server running. I ran it on Kali before. I'm not quite sure what the best thing is to use now. So you'd run a server, then install this Drozer agent on the phone, and turn it on. Now it's listening on this port, 31415. You connect with the server, and now you can do security scans on the app, on the phone, from the other computer by getting this app to send signals off inside the phone. And so we'll play with that in later projects. Now, since the apps are each running with a different identity, and the apps cannot see the other app's data, then how would one app send data to another app? There must be some way to do that, and one way to do it is this kernel module for inter-process communication. So apps have 4 parts. There are activities. These are the visual screens you see, like the login screen, splash screen, whatever you've got. Then there are services that run in the background, like databases, and don't have a GUI. They're just used by apps. There are broadcast receivers that listen for incoming events, like an SMS or an email or whatever it is your app wants to listen for. And there's content providers down here, like databases. So I probably shouldn't have used that example of databases as services up there. Anyway, those are the 4 parts of an app. And so you can view the running services on your phone, and you'll see you've got a list of them here. It's just a list of your running apps. And what kind of signals? Let's see, I see some questions here. The signals are just messages sent from one app to another. Your inter-process communication, they call them intents. They're like network traffic, but they're just local inside the phone. When I tried Android Studio on M1, yeah, it's running Chemo. Can the method of different UIDs for each Android app be seen as another OS system? Yes, that's a fair statement. You could call this the Android sandbox. That is their security barrier between apps. And BusyBox is just a package of Linux tools, that's all. You install it, and then you have a bunch of standard tools like showmode and ls and grep. That's all. The BusyBox just gives you more of the standard Linux utilities you'd find in a normal Linux install. So here's the Android manifest. It lists all the components in an application, except broadcast receivers, and it contains the permissions. So intents are what we were just talking about. Intents are what Binder gives you to send a signal from one app to another. And so here's an intent. You create it with this code. I create a new intent. I now send google.com. So this will send this URL out as an intent. It will then go to anybody that's listening for that intent. If you only have one browser or a default browser, it will open that in a browser. If you have several apps that can handle that kind of data, it'll pop up a screen saying, which one of these apps would you like to open this in? That's what intents do. It's essentially the same thing. If you open the Windows box and you open the Run box and you just type something in there like a URL, it will automatically open in Internet Explorer or Edge. It's just a bit of data which then flies into the device and says, can anybody handle this data? And it'll only work if somebody has an intent handler that can handle this prefix here that tells it, I've got an HTTP data. Is anybody listening for HTTP data? For example, Skype. It used to be when you put Skype on your phone, it would listen for Skype in commands, and you could trick people into clicking a link in your browser that went to Skype. It would automatically make a Skype call. So it works by these prefixes. All right, so that was said, this did not specify the target app, so anybody that is listening for HTTP will get it. It'll open it with one app or more than one app has it, then it'll pop up a box asking the user which of the available apps to use. So you can have intent filters. I need an S here. I fixed it if I get there. So here's what you have if you want to listen for that. You listen for the scheme HTTP. And now this app will listen for HTTP signals coming in and respond to them. All right, and so you can have an explicit intent. Instead of just putting in data and hoping that any app will listen, you can target it to go specifically to that app, which is another thing you might do. All right. And so when you run an app, the OS boots, the Zygote process starts, it then listens for other apps that launch. Every app causes a fork, which launches a new process, copying the OS system process and then diverging from that. And the libraries are shared between VMs, just like they are on Windows. You only have one copy of a library in memory, which is shared by all the apps that are using it. So that's the overall structure of apps and memory on Android. And got another Kahoot here. I want to find 6A, which is here. Good. Getting happy with the Kirk here. Wait, people still coming in? This shows the right attitude, trying to do injection on the Kahoot. I've seen that before. That's a good attitude. It doesn't work, though, although Caitlin did hack the Kahoot once. But it's not that easy. Well, good for you. That's the right attitude. Hack the planet. Seconds to see if there's more coming. Apparently, okay. All right, I think we got them. Let's go. All right, so what's the IDE for app developers? I know Visual Studio, maybe it has an option for doing it now, I'm not sure. They keep adding more to Visual Studio. I don't know if you can write Android apps in Visual Studio. You didn't used to be able to. Android Studio is Google's product to write apps, but Visual Studio can do a lot. I know they now have a COBOL extension for Visual Studio. You can do almost anything in there. There might be some Android capabilities in Visual Studio by now, but there didn't used to be.
You probably just write it in Visual Studio and move it after if they want. Like, actually, that's kind of extra work. Never mind.
Yeah, well, no, but a lot of people a lot of developers love Visual Studio. They want everything to be in Visual Studio.
Yeah, it's my favorite as well. It's so good. I've compared it to many others, and it's the most comfortable for me. And like it
Yeah.
works, it's clean, satisfying, dark mode. Well, everything. I just like it.
Yeah, you can do Java, right, in Visual Studio?
I do. I used to do multiple program languages like HTML, Python, and it works every time.
It doesn't do Java. I'm not sure about that. Because Android's Java. Anyway,
It should do Java.
it should do Java, and maybe there's a way to add Android too. I think there's a lot of extensions and stuff, so there might be some way to use it instead of Android Studio. I've never tried, but I know a lot of people love it. In fact, I'm working for a corporate consultancy. I'm a consultant for a bank, and they want everything to be in Visual Studio. So I'm using it more than I would have myself otherwise. That's what their developers like. So, which tool will let you install apps? ADB, of course. Now, in that gig, they're actually using Visual Studio on Linux, which they're still comfortable with. So anyway. I, of course, used Nano, but they didn't want to hear that. I mean, so they told me to use Visual Studio, and that's what I did anyway. All right, so where do you find an app's signature? Yeah, VS Code. Yeah, it's VS Code is what I'm using on Linux. On Windows, you get the full Visual Studio. Technically, you use ADB and Android to install it. Well, yeah, Android is a very vague answer. You know, Android is, yeah. All right, ADB is the most direct answer. All right, that's the meta-inf is where the signature lives, the meta-inf folder. All right, so which process used pin SSL? Yep, G-Talk service, all right. And which module runs IPC, which is inter-process communication. That's Binder, they call it. All right. Now, Drozer is a hacking tool. Binder is an integral part of Android. All right, and what app components does the user see? The activities are what the user sees. All the rest of these things are behind the scenes. All right. I don't know who that is. And V is the two-time winner. So it's Sean. All right. Good. I'm going to stop this recording then.